In this video, I'll introduce the concept of a cash flow, and then I'll discuss a framework for using information about cash flows to make decisions. This framework we're going to talk about involves terms like present value and future value, and more generally, the time value of money. Now, to keep things simple for now, we're only going to deal with cases involving one cash flow. So we'll start with the single cash flow case, and then we'll move forward. Let's start the discussion by establishing why we care about cash flows. Broadly, there are a couple of reasons. First, we can use cash to buy stuff right now. Second, in the event we don't want to buy stuff now, we could instead invest cash now in some asset that grows, and then at some point in the future, we can use that grown cash to buy even more stuff. So think buy stuff now or buy stuff later. We'll often refer to this first activity as consumption, and we'll refer to the second as investment. Of course, both of these ideas would apply for us as individuals in our personal lives, but that also apply for the firms that we either own or manage. And this brings us to this broad summary statement that any way you look at it, cash flow is king. Okay, so what is a cash flow? Well, cash flow has three critical features. The amount, so here I want you to think about some number in dollars. The direction, so here I want you to think about an inflow or an outflow, or perhaps a positive sign or a negative sign. And then third, the timing. So here I want you to just think about when does the inflow or outflow occur. And so, for example, we could say a cash flow is a $100 inflow 2 years from today. A timeline is a super useful tool for visualizing cash flows. And so I'll utilize timelines pretty extensively in the quantitative parts of what I do in finance. And so here I just want to offer a few quick notes on how to properly set up a timeline. So a timeline is always going to be a line that contains a handful of evenly spaced tick marks that represent discrete moments in time. It will always denote the actual time being referenced on the top of the timeline, and so we'll start with time 0. So tick mark 0 always represents today. Tick mark 1 represents the end of the first period, 2 the end of the second period, and so on. And so here we have a 5-period timeline. Now the periods can be anything you want. And so for this timeline, we'll just call this a yearly timeline. So every tick mark represents the next year. Final piece of the timeline is the actual cash flows, and we put those underneath the timeline. And so for our $100 inflow that we described in the previous slide, that's going to show up right here. Okay, now that we've got a timeline set up, we can go to work. The main questions that we'll be asking are going to start with cash flows that are presented on the timeline and then determine their equivalent value at other moments in time. So, for this case, we're going to start with a time 2 cash flow, and we could ask the question, well, how much is this cash flow worth to us right now? And so we'd be moving this way in the timeline. That would be asking, what is the present value of this cash flow? Alternatively, we could move the other direction of the timeline. So we could say, well, how much is this cash flow worth to us 5 years from now instead of 2 years from now. And that would be solving for that cash flow's future value. Let's work a basic problem in the context of a bank account. Here's the problem. You deposit $1,000 in a bank account today. How much should the account contain 3 years from now? Step one here would be to set up a timeline. I'm going to use an annual timeline, so my tick marks reference years. We know that we have $1,000 at time 0. Okay, so since we're asking how much the account's going to contain 3 years from now, we're going to take the $1,000 and we're going to move forward. So we are moving from a present value to a future value. Of course, to complete this problem, we need one other bit of information. The missing information is the bank account's interest rate. Simple definition of an interest rate is the rental price for money. It's typically expressed in annual terms, so think percent per year. And so when you deposit money in a bank, the bank pays interest to you. So that means the bank is renting your money from you. Put another way, you are the lender, the bank is the borrower. Now, depending on the source and the context, an interest rate will show up in math problems as an R, or perhaps an I, or perhaps a K. So don't get confused by seeing either an R or an I or a K in different contexts. So for now, I'm going to choose R. So I'm just going to use R to denote the interest rate. Okay, back to our problem then. So let's say that the account pays an annual interest rate of 4%. So this means that the bank will pay you 4% of your account balance, or the principal on the account, each year. And so to determine how much the account will contain 3 years from now, let's just set up a little chart and go 1 year at a time. Okay, so let's start with year 1. So the beginning balance in year 1, which shows up as time 0 on the timeline, is $1,000. So that's the beginning principal in the account. Interest is paid over the course of the first year on that principal amount, and so the calculation is simply the interest rate of 4% times the beginning balance of $1,000. So that gives us the interest of $40 in year 1. The ending balance in year 1 is simply the beginning balance plus any interest that is paid, and so that is $1,040. Then we can just roll forward. Right, the beginning balance in year 2 is the same thing as the ending balance in year 1. So we're going to start with 1,040 here, and then to calculate interest in the second year, we're going to again multiply the interest rate by the beginning balance. And since the beginning balance is a little bit more in the second year than in the first year, the interest in the second year is a little bit more as well. It's $41.60. We'll add the interest to the beginning balance once again and get an ending balance of $1,081.60, which becomes our beginning balance in year 3. Continuing on with the same process, we have $43.26 in interest in year 3, and an ending balance at the end of year 3 of $1,124.86. Again, this is the ending balance at the end of year 3, which is exactly what we were looking for. And so this is the answer. And so all of this math leads us to a final statement. We can say $1,124.86 is the future value 3 years from now of $1,000 invested today. And so we have the PV of 1,000 and the FV, and I'll go ahead and add a subscript of 3 to denote that this is a time 3 future value of $1,124.86. Another way we can say this is the following. $1,000 invested today and $1,124.86 3 years from now are of equivalent value to me. Okay, we're almost done here. Now, these calculations are a little bit long and tedious, so let's clean everything up and get to a nice little formula. So the first thing I want to do is note that the ending balance here is always the beginning balance times 1 plus the interest rate. So let's take the middle column and simply make that 1 plus the interest rate. And so I'm going to say the beginning balance times 1 plus the interest rate is equal to the ending balance. And so we can insert some numbers here. So I'm going to multiply by 1.04. Again, I'll multiply by 1.04. And again, I'll multiply by 1.04. So why is this useful? Well, note that I've simply multiplied by 1 plus the interest rate 3 times. And so if we want to go from the present value to the future value, I can simply acknowledge that $1,000 times 1.04 raised to the third power is equal to $1,124.86. So making use of the subscripts that we had on the timeline, then I can say that the present value at time 0 times 1 plus the interest rate raised to the third power is equal to the future value at time 3. Now, this is not only true for time 3, of course, it would be true for any time in the future. So we can say the future value at some future time n is simply the present value at time 0 multiplied by 1 plus the interest rate raised to the nth power. We called this process of moving from a present value to a future value compounding.